Good morning, guys. So I'll be having another example. At least I have two example. Maybe I can give example at the board. So this is just a preliminary. So that also as a sort of me practicing. So I've already made a video, of course, as an example. So I think I'll be solving basic. So let's try this one. At least at the bottom, you have your manganate and your nitrogen dioxide reacting with your MnO2, I mean producing MnO2 and NO3. So we can write it down, MnO4 negative. So you have an MnO4 negative, and then you have a plus NO2. Then NO2, then it produces um, MnO2 and NO3. MnO2 MnO2 and then plus NO3 negative. MnO3. So okay. So that is the equation. So this occurs in basic solution. So basically, uh, at the last at the last part, you will be seeing OH because that's an indication that it is in the basic environment, the OH, the hydroxyl. Since the presence of your hydroxyl will of course react with your acid, if there is an excess of OH, so basically it would be basic solution. And anyway, so first is you have to identify what substances are undergoing oxidation reduction. So basically, oxygen, of course, is not the substance. So therefore, you can expect that magnesium or manganese and nitrogen would be the reducing agent or the oxidizing agent. So we will see. Oxygen here is a negative 2. You go back to the rules. In balancing, you start with the same rules. You first identify the substances that undergoes loss or gain of electrons. And then next, you will balance it just like an acid, and there is only an extension for that by putting OH, and then look at it as you look at this picture probably. So you have negative 2 here, so negative 2 times 4 you would have a negative 8. Negative 8, then since the whole MnO4 has a negative 1, so basically you would see that manganese here has a positive 7. Positive 7, 7 minus 8, that would give us the whole negative value for the MnO4. How about for NO2? So here you have a negative 2 times 2, that would be a negative 4 for oxygen. So basically nitrogen here would have a positive 4. Okay? So how about here? Oxygen would have a negative 2, multiply it by 2, that would be a negative 4 still. So you can see that manganese has a positive 4 because positive 4 and negative 4, that would give us no charge for the MnO2. How about for nitrate? Same as the last problem that we did. You have a 2 negative, multiply it by 3, you would have a negative 6, of course, negative 2 for oxygen. So basically, since the nitrate has a negative 1, nitrogen here would have a positive 5. 5 minus 6, that would be a negative 1. So you can see that your manganese is from positive 7, it becomes a positive 4. So basically, it gained electrons. So if it gained electrons, manganese would be in the reduction process, half reactions, and it is an oxidizing agent. Okay, so we first write the reduction process, reduction that happens to MnO4. So we write back the MnO4 negative, then plus, and then it goes to MnO2 without charge. So we balance oxygen just like an acid. We balance oxygen with H2O. So we can see that we have an excess oxygen here. So basically we have 2 H2O here since it's lacking 2. So there would be 4 oxygen. Okay. And then next for every hydrogen, since there are four, so we put four hydrogen proton, 4H plus. Sa that is balancing the atoms. Manganese, manganese, one manganese. You have four oxygen. You have 2 plus 2. You have four oxygen, and then hydrogen. You would have four H plus for H, and then you would have four. So the balance, it is already balanced in terms of atoms. Then you proceed with balancing the charge. So here you have a zero charge, while here you had a 4 plus a 4 minus a negative 1, so that would be a positive 3. So basically you'd add a negative 3 for electrons, so that this whole thing would have no charge. So this is already balanced atomically and by charge. We proceed with the oxidation half reaction. So the oxidation, and then we know that nitrogen here would be NO2 would be the reducing agent. So NO2, and then it produces NO3. Okay, negative. Okay, so we balance oxygen with water molecule. How many? There is one, since there are already two here. So we put H2O, one H2O, and then we proceed with balancing it with, um, of course, balancing it with what? What? Two hydrogen. What ko yung mukha mo. So you would have two hydrogen, you would have two H plus. Okay, so that is already balanced atomically. Nitrogen 1, you have 3 oxygen, then you have 2 hydrogen, 2 hydrogen. Then you balance the charge. So you have no charge here. While how about this one? You have a negative 1 plus 2, negative 1, because this is the whole nitrate, the negative 1 plus 2, you would have a charge of how much? 1 positive, positive 1. Okay, positive 1. So in order to compensate that, since there's no charge here, you have to add 1 electron here. So 1 electron and a positive 1, that will give us a no charge on the right side. So it's already balanced, as you can see. You have 3 electrons here, you have 1 electron here, you have to multiply this by 3. So basically the last one would be a 3NO2, and then you would have a 3H2O, then you would have a 3NO nitrate, and then you would have a 6H plus, and then you would have a 3 electrons. So basically, again, you have to balance this an acid as if, and then you will put the OH on both sides. But anyway, we balance it first. The all in all, you have MnO3. I think this is already balanced. You have 3 nitrogen. You have 3 nitrogen. You have 6 plus 3. That would be 6 plus 3. That's 13. So you have 9 plus, oh my, 9 only. So 3 plus, so 3 times 2, that is 6 plus 3. That would be 9. Sorry. And then how about for hydrogen? You would have 6. You would have 6. Okay, so that's already balanced. Then we write the MnO4. Plus your 4H plus, then your 3 electrons, and then you would have MnO2, then plus 2H2O, and then plus you would have NO3 negative, and then you would have a 2H plus, and then sorry, I'm not, so maybe control Z. Nagkakamali rin ako kasi tao lang din ako. So 2H2A, 2H2O. Okay, so that is the upper part, and then we sum that. Ooh. And then you would have 3 electrons, of course, first electron, so that you can see that it should be balanced. Next is water molecule. You have 3H2O, you have 2H2O, so you have 1 H2O here. How about for the hydroxyl? You have 4 here. How about you have 6 here, so you would have 2 here. 2H plus. 2H plus. Then you would have 1 H2O. So you would write it as 3NO2. Sorry, I will start with MnO4. So you would have an MnO4 negative plus your 3NO2 plus you have still one water molecule, one. So next is MnO2. So you have MnO2 here, O2, and then plus next is the NO3 negative. So how much? That would be a 3NO3 negative, and then you would have a 2H plus. So that is the acid balancing. So next is step 5. Step 5 is you should put an OH here, 2OH, 2OH to compensate for that acid because we are in basic solution. And you know that this will form the another water. Okay? And then since you've add 2OH here, I will also add 2OH here. So that's the rules. So here, this would become water. So you would have two, two, so you would have how much? Two, you would have four. No, 2H2O. Yes, 2H2O. So you have 2H2O, 2H2O. So you would have 4, 2, 2. So that is, and then you'd have 2 oxygen. How about for the charge? Since this is positive, this is negative, so it cancel off because again it's a water molecule. Then we write down 3NO3 negative and then MnO2. And then we can see that uh, you have here a water molecule and a OH, 2OH negative. Okay, and then you would have a 3NO2 and then you would have an MnO4, but still you have to cancel the water. You have one water there, you have two here, so basically you would have one water molecule here, one H2O. So as a product you would have a water as a product, then you would have 3NO3 negative, then you would have an MnO2, no charge, then you would write it as MnO4 negative, sorry, it should have charge, and then you would have a 3NO2, no charge, and then plus your 2 hydroxyl. Again, the presence of this one will tell you that it is in basic solution or in basic environment. So that's what we call it. So charge, first the atom, manganese, you have manganese 1. Oxygen, you had 4, and then you have 6, so that is 10, plus 2, that is 12. Here, how about this one? You have 2 plus 9, that would be 11, plus 1, that would be 12. How about for your nitrogen? You have 3, you have 3 nitrogen here. How about for hydrogen? You have 2, you have 2 hydrogen here. So I believe that's already balanced. How about charge? You have negative 1 and a negative 2, that would be a negative 3 here for the whole charge of the left side. Then you would have a 3 times 1, so you have a negative 3. So you can see that it's already balanced by atoms and by charge. So basically this is the balance equation written in from what is given. So you can say that A is equal to 1, B is equal to 3, C is equal to 2, D is equal to 1, E is equal to 3, and then F is equal to 1. So again, A for 1 that would be A, 3 that would be C, 2 would be B, 1 would be A again, 3 E would be 3, C, and then 1 would be A. So that should be your answer for a probable quiz next time. So thank you for listening, guys. I hope you are enjoying, or I know you're not enjoying, even though it's what. So I did this for, let's say, maybe you'll be busy with um, what do you call this? The um, charter days, charter day. So it depends. So if we have a class or we don't, at least I've already made some videos. Thank you guys for listening. I hope you have a great day. So I've already two example. Maybe I can make some. Depends on my time. So I already make two. But I think I'm sure I can make another two during the face-to-face discussion. So if ever you'll be saying lot still example, so I've already made video and then a face to face. Thank you guys. God bless.